Hi, my name is Clark Ellings. This is the second in a series of lectures on demand-side management that we prepared for the University of Minnesota. I'm with the Electric Power Research Institute. This set of this part of the discussion focuses on the attributes of demand-side management that are now being called demand response. We've actually got a more formal definition here of demand response that comes to us from the Federal Energy Regulatory Commission, which defines demand response as changes in electric use by demand-side resources from their normal consumption patterns in response to the changes in price of electricity, or to incentive payments designed to lower electricity use at times of high wholesale market prices or when the system reliability is jeopardized. Kind of a mouthful. Basically, what they're saying is that the demand response focuses primarily on lesser time periods where there are peaks in either demand or price, so as to cause programs to be activated which would encourage consumers to make changes in their use of electricity during those periods. A good way to illustrate this is from this diagram, which actually goes a little beyond the demand response definition that FERC has. It was originally done, the diagram that is, by a entity called Red Electrica, which is the transmission system operator in Spain. And Red Electrica was suggesting that their need to employ demand-side management are at a couple of critical peak times. As you can see from the little workmen with their jackhammers, these two critical peak times occur at a variety of, or at two different times of the day. And they're inferring by this diagram that what they might like to do is chop away at those peaks and then using the little guys with the wheelbarrow and the shovel fill valleys instead. And demand response can have that impact. So as you cut, for example, production, or you let a building heat up because of changing usage during those peak periods, there will be a rebound effect, which in essence will cause, in the end, for some of that energy to be shifted to other periods of the day. In employing demand response, one of the objectives is to try to increase load factor. And here's a plot which is a couple of years old, but still fairly representative of load factor of a number of countries and utilities. As you can see, it ranges from a 77.7% in Korea. That is to suggest in Korea, at 77.7% of the time, their system is utilized. So as to say, at the average of the utilization of that system is 77.7%. And look down the list, and you see the USA is quite low at 59.8%. So there seems to be, at least inferred here, a significant opportunity to reduce peak demand in the U.S., which would in turn raise the load factor and enhance the asset utilization of the electric utility system. One of the other reasons for being interested in demand response is because the renewable resources that we are now very interested in promoting and adopting in our power system need what we call dance partners. If you look at the top right chart, you'll see that there is a plot of the production, or in this case, fraction of output, of nameplate output, of 104 wind turbines at 4 locations in one region. And those are hours that were plotted in 2004. And if you look at that variability, you can appreciate that for those who have studied system stability, that can have quite an impact on the electric power system. We have to have balance in the power system. So as the production of those wind turbines moves back and forth, and very rapidly back and forth, we have to be in a position that we can backfill their production with other resources. And I'll talk a little bit about what some of those are, but clearly demand-side management is one of them. You might also look just to the left of that chart and remind ourselves where the average wind power production in the U.S. is. It's principally in the Midwest, and that just adds a complexity of distance. So not only do we have the question of variability, but we also have the dynamics of the power system that change quite a bit over long lines. So we need some kind of renewable resource that would allow, some kind of resource that would allow us to balance against the renewable resource so we can make full use of wind power. And if you think for a moment solar is much better, no, it's not. Here's on the bottom right-hand side, solar intermittency, and then a plot, if you will, just left of it, which shows you where the population centers are. So here we have these enormous resources that we want to utilize, but we have this inability to effectively utilize them unless we find a balancing resource. Demand response is one of those balancing resources. I might say that some of the others include fast-acting combustion turbines that we can turn on and off, storage in the form of compressed air compressed in caverns where we exhaust that air and use it to turn an air turbine and control that air turbine in balance against the variable resources. Of course, batteries, pumped hydropower, and in the bottom right-hand corner, fast-acting demand response. Demand response has evolved quite a bit over time and is not fully implemented, as you might infer from this chart, but we have in the industry utilized for some time voluntary load reduction programs where you would get a prearranged call from a utility asking you to curtail your usage. This basically was most popular in the East, where utilities arranged with their commercial and industrial customers, prearranged, that look, if I call you and I have a critical need, will you cut back on your process? Will you turn off some lights? Will you cut back on your industrial process? And those prearranged programs were fairly rigorous. They didn't involve any incentives, but they had quite a cadre of participants, in part because they were only utilized maybe 4 or 5 days a year. You would arrange with very specifics with the plant manager, his home phone number, cell numbers, fax numbers, all set up in a rigorous way so that you can implement this. Another one of these that we've all experienced are public appeals, where when a utility is in a critical situation in terms of capacity needs, they have the ability to get on the radio, TV, and the like and say, please, it's a critical time for us. We've got a problem, hot day, whatever it may be. We've moved from that a little bit, still not giving up the voluntary programs, but we moved from that a little bit and started employing what are called interruptible rates, where we have rates that are either off-peak, where in fact what we do is we essentially offer consumers a lower price if they'll use energy at night, and then encourage them by doing so to move some of their what would have been daytime use to nighttime. We've had some programs of so-called direct load control, where we actually put a relay on consumers' air conditioners or water heaters and occasionally their pool pumps. And we, with a remote communication system, actually turn those systems on or off, and do that in a way so as to control the demand at time of peak or when there's a critical situation. We've also had indirect load control where, because of encouragement, either through tariffs or incentives, we might put time clocks on swimming pool pumps or time clocks on other devices where the load is controlled, we'll say, indirectly. And that could also include phone contact or faxes that ask the customer to activate some kind of control device. These days we've moved to more sophisticated systems, one involving time-varying pricing, and these are not yet widely implemented, but here's where you actually have rates which vary either with the time of day or time of use. Some of these more sophisticated ones actually have critical peak pricing, where a number of hours in here will subject you to an extremely high price. But if you're willing to go with that for the rest of the year, you'll pay a much more reasonable price. There's a variant on that called peak time rebate, whereby looking at your consumption at peak time and comparing it to your average consumption, you may get a rebate. And then there are feedback displays of various kinds, which are monitors and the like that you would have in your home or building, which show you what your demand is and essentially encourage you by the pure peer pressure of seeing your own demand and knowing its impact on the bill to go make some changes. What we're moving to is something called dynamic pricing or auto DR, auto demand response, where a price signal is sent or a signal of some kind is sent, and a local device exercises some intelligence to enable a change in how energy is used within that building or home. Here are some estimates of what these kinds of programs might mean across an array of utilities and their programs. Look at the percent reduction in peak load from a variety of these, all the way from time of use on up through critical peak pricing, and then critical peak pricing with some kind of technology. And you see some of the results of this in terms of peak reduction now, just peak reduction, are out just unbelievable, where you can see reductions easily in the 5% range for price signals, all the way up to almost 50% for critical peak pricing with a technology. This is now, again, just looking at the reduction in demand at time of peak and not the reduction in total, which of course would practically deprive that particular consumer or customer with electricity. So there is a resource out there. The impact of these reductions would be to defer the need to purchase very expensive peak generation on the wholesale market. And ultimately, it would also result in less need to construct peaking devices like combustion turbines that only run a limited time of the year. In the voluntary load reduction program, what we've done in the industry is we've actually gone out and collected, as I suggested, rather detailed information with backups and contacts, and we do this every year and we refresh it, and then we ask that customer what the impact they can offer us. Some of these programs actually put in, as I suggested, communications devices. This was one by the Long Island Power Authority. What WIPA, as they're called, does is they use a unique direct load control program with residential and small commercial customers. They have a two-way communication with programmable thermostats. They control central air conditioning, CAC, and pool pumps. And they also have an internet-based system which provides remote customer access. The two-based system provides immediate load control verification, so they control over 23,000 residential air conditioners, over 6,000, almost 7,000 small commercial and industrial air conditioners, 2,600 and some pool pumps. And so in total they have 48.6 megawatts under control. Imagine then, time of critical peak, getting hot in Long Island, they have a resource here equivalent to almost 50 megawatts of generation. And here is an example in its early days of the actual use of that program and the available reduction that it achieved, if you will, demand reduction response. You see the demand reduction response plotted in green. It's a substantial response where there's some recovery. Notice that little red spike at the end, and that's because if you take air conditioning and you shut it down, once you bring it back up again, if that building is hot or it's gotten warmer, even though the evening cooling may have begun to take place, you'll get a little bit of a rebound effect. Another good example of programs like this, and one of the largest, is Florida Power and Light, or FPL as they're often called. They have a direct load control program for residential and small commercial customers. 1,400 megawatts of potential reduction. Over 700,000 customers. Their peak impact they have seen is in the range of 750 to 850 megawatts. They find that they can use it for emergency control and get something even in excess of that 1,400 megawatts. And the cost per customer for them is about $200 to put the system in, and about a $40 per year incentive. Putting the system in, by the way, requires a radio receiver or a receiver of some kind, and then a relay, so that the signal is sent, the relay interrupts the operation of the device, and that's how essentially they get the benefit. The $200 is to install that original equipment, and then the incentive, the yearly incentive, is to kind of make sure that people hang on. There is a problem with these programs. If you use them too much on too many hot days, people look at that $40 a year and they say, this isn't worth it. So we keep searching for something that's more automatic, more dynamic. I'll talk about that as we go on. Southern Company is another good example. They have reduced new generation needs by over 2,000 megawatts. That's about equivalent to 2 very large power plants. They have nearly 1,800 megawatts of interruptible service, mostly with industrial customers, 89 megawatts of direct load control with residential, and then they have a program of peak period pricing through time of use rates and real-time pricing, such as I described a few minutes ago. And they have 400 megawatts that they get through those programs. And they get really high ratings on customer satisfaction and value. Part of that involves really good communication with the customer, so that the customer knows that what they're doing is the right thing and that they're helping to benefit and keep costs low overall. According to surveys that FERC has done, the potential peak load reduction that they see in the United States, their information gets better, so the numbers seem like they continue to climb. Current estimates are well over 50,000 megawatts of peak load reduction that could come from demand response program. One of the issues there, of course, will be that assumes everybody is participating, and as you might guess, not everybody will always participate. Not everybody will be utilizing their equipment fully at the time that you want the reduction, so that the reduction won't manifest itself. And if these are voluntary, which in our society still seems to be the case, not everybody is going to sign up for them, no matter how appealing you make your marketing campaign to get them to sign up. So, a little quiz on this issue. Demand response reduces the demand for electricity at all hours of the day or night, usually during peak periods, or when wind turbine generators operate. And of course, you probably chose number 2. Its focus is during peak periods. Second question, demand response programs may include direct load control, interruptible electric service, critical peak pricing, or use of efficient appliances. Well, the answer here is the first 3. The fourth one is thought more to be a program of energy efficiency. I hope you've enjoyed this second in our series of lectures.